Subspaces are now a vector space that lives in a vector space, or it's a subset of this vector space. Typically they'll say H is a subspace and V is the vector space. So you could think of the vector space as like the whole universe kind of thing, and then the subspace could be like a galaxy or galaxy cluster, some smaller section of the universe. Subspaces are a little not easier, but they have only 3 rules. So they have the zero vector, and then closed under addition, and then closed under scalar multiplication. So, examples of a subspace. Damn it. For example, the line through the origin, y is equal to 2x. This is an example of a subspace of R2. It contains a zero vector. If we plug 0, 0 in, we get 0 equals 0. We can close it under addition, x1, comma 2x1 plus x2, comma 2x2. And then that would just be x1 plus x2, comma 2 times x1 plus x2. And this is just x comma 2x. If we want to simplify it a little bit, we can also have a scalar multiple. And that's still on the line. But if we were to say y is 2x plus 1, is this a subspace of R2? And the answer would be no, because if we plug in y is equal to 0, x is equal to 0, we get 0 is equal to 1, so it doesn't go through the origin, so it is not a subspace. It also would not satisfy closure under addition. We can also take 2 points. Let's take 1, 3 and 0, 1. 2 points. We add them together. That should give us 1, 4. But 4 does not equal 3. So it's not closed under addition. If we were to also scale let's say scale 0, 1 by 2. That would give us 0, 2. And 2 does not equal 2 times 0 plus 1, which is the 2x plus 1 condition. Here, 4 doesn't equal 2 times 1 plus 1, which would be the equation of the line 2x plus 1, or 3. 4 doesn't equal 3. You could generalize these to you could generalize it to any point. We have 2x1 plus 2x2 plus 1. And with y1 and y2, that should be, so y1 would be 2x1 plus 1. y2 is 2x2 plus 1. And so we're just expanding these out. There's a 1 right here. And then you get 2x1 plus 2x2 plus 2 equal 2x1 plus 2x2 plus 1. If you were to cancel all the terms, you get 2 is equal to 1, and that is just not true. And then you could do a scalar multiple. And then cy would be 2 times cx plus 1. Okay, I got a little confused doing this, but I think I understand it now. I understand my notes now. So we have cy is equal to 2 times cx plus 1. And then we say cy is 2x plus 1, and that's 2cx plus 1. Now we're multiplying this entire thing by this constant c. So that would give us 2cx plus c equal 2cx plus 1. And this would only work if c is equal to 1, but c can equal 2, 3, 0, pretty much anything. And this is only working when c is equal to 1, so it is not closed under scalar multiplication. And that is pretty much it. Thank you.